let's try another example, and this time we will put together this instruction. And let's see, so I'm just going to keep adding to the list of instructions that I already have, and I'll just convert them to lowercase in my style. So the next sample here is very similar to the previous one. We keep working with this add instruction because we just use the same opcode over and over and over again because it's so simple to visualize. And so this time we're going to use a register ESI as memory address. So remember, anytime we use square brackets, it means that we're going to retrieve the source operand, this right hand side operand, from memory. And therefore, inside the square brackets, we have an expression which computes the address. So let's do this. Let's load, again, something very similar to that I did before. I just copy and paste this move instruction and set ESI with offset of temp1. Right? So we do exactly the same a loading address, and I'm setting it to temp1. And then I know that the size of this double word is 4 bytes, right? So this integer 1 occupies 4 bytes in computer memory. Therefore, in the next integer in memory is located 4 bytes further out, away from temp1. Therefore, if I use +4, this is an example of this displacement, and it looks like the idea behind it is that the assembler will realize that 4 is quite a small number. It could fit into 1 byte value, and so the displacement that is going to be used with, this is the example of displacement +4. The displacement will be an 8-bit long displacement byte added here. Okay, and before we run this code, let's also move into register EAX 0, for example, right, just to set it equal to 0. Okay, so let's see how this works and what we get in EAX after assuming using this displacement relative to the address in ESI. Let's try this. Build, and then run through debugging session, start debugging. Again, I will just step forward to this area of the program by pressing F10. Okay, just move here. Register EAX is set to 0. Move into ESI address of temp1. So apparently ESI right here is the address of temp1 right now. And then we are about to add something to EAX. So I press another F10, and you can see that 2 was added to register EAX. So this is this mode where we have a register used as address of operand in memory plus displacement. So let's visualize our displacement in memory by switching to disassembly view. If you don't have disassembly view, you can always just right click and say go to disassembly. And so once again, this sort of like matches perfectly our slide. So the opcode is 3, the mode regrm byte is 46, and this displacement is 4. And before we move on to the next example, I would like to show you, let's stop this debugging session for now and close this console window. And let's modify this example slightly. I will copy and paste my code, duplicate it. Again, I will set EAX equals 0, and again I'm loading ESI with offset, although I don't need it, it never changed. Actually, yes, I would like to change it. I would like to set it equal temp2. So this time ESI is pointing to memory of temp2. Okay, so it's pointing to this memory instead of temp1 in previous example. And I really need to scroll this back up a little bit so we can see the data segment. And this time our ESI register is pointing to temp2. But I can now say -4 to move to update this address to at runtime, to say that I want to go to the previous integer in memory. Let's see if this works. Okay, and so the displacement can be both positive and negative relative to some sort of base address. Let's press F5 to start our debugging session, and quickly again bring up the registers into the view, and I will just I guess we can there is a better approach rather than pressing F10 and not changing this breakpoint. You can always click on the line that you like and right click and say run to cursor. Okay, so if I say run to cursor, it stops where I want it to stop, so that's nice. Okay, so so the previous value of EAX is about to be erased. We're going to step over by F10, so EAX again is 0, and we're going to say move ESI offset of temp2, so this time is going to be offset of this variable. Okay, so ESI now indicates this value, and the next add instruction is supposed to add 1 to register EAX. Okay, and so here we go. So this works, and quickly switch to disassembly one more time. You see that the value of this displacement, okay, so this displacement value is FC. So if I copy FC, right, into my calculator view, where I just clear this and switch to hex, right, and make sure that I switch to byte mode, and in hex mode paste this, Control V, paste this value, Control V. Oh, it doesn't like it, so I'll just set it manually. The value is FC, right, FC. So of course decimal value is -4. Okay, so this is -4 displacement, because what we just did was that we pointed ESI right here to this location in memory, and then the location of the previous integer in memory is at address of this -4, and you can see that our disassembly shows that we now have a negative 2's complement encoding displacement or offset stored in a 1 byte size displacement. That's why it says here disp8 means that this displacement is only 8-bit size. If our displacement was larger, like, you know, bigger number right here, of course this displacement would grow in size and become 32-bit as soon as we step outside of the possible ranges in just 1 byte 2's complement value.